Welcome, everybody. I'm gonna talk about writing Android libraries. My name is Emanuele Zattin, and I'm actually Italian. Uh, I was born in Padova, which is a few hundred kilometers east from here. But I've been living in Denmark, in Copenhagen, for the last 10 years, and I'm turning blonde. I've always been an automation enthusiast. I'm a big fan of the Jenkins project for continuous integration. I've been a committer to the project and own several plugins for the ecosystem. And right now I'm a Java developer at Realm. And Realm is basically just an on-device database that aims to be easy to use, cross-platform, and fast. And that's all I'm going to say about it. I'm not here to do a sales pitch. So why would you want to write a library? I can see mainly three reasons. The first is modularity. And modularity is dividing your code into smaller logical units that have a clear interface that you can change with one another. That makes testing easier and makes changing one module with the other easier. The second one is a consequence of modularity, which is reusability. And reusability means that you can reuse your code in several projects, several platforms, several frameworks. And there's a third reason that I've been struggling a bit trying to find the right word for it. I came up with this. Vanity, or sometimes you write some code, you solve a particular task, and you think you did it in a nice way, in an elegant way, and you just want to share it. You want to share it with the rest of the world, you want to share it in your organization or wherever you work, and that's when vanity is part of it. I mean, there's some ego playing there, and you want your name out there, and you want to be recognized for some. Why writing an Android library in particular? You might be writing just a Java library, but sometimes you need to write an Android library. What is that? I mean, if you do anything that's related to UI, if you do anything that relates to any kind of sensors of the Android device, or if you do use some anything from the Android framework, such as loopers and handlers and all this kind of advanced stuff, or even if you use native code, you will need to do specifically an Android library. For native code, of course, you need to consider that you don't want to ship a library that builds a Windows DLL inside it. You don't want that. So how hard can it be? Just fire up Android Studio and start a library project. But no, you can't. There's no option in Android Studio to do that. This is the situation right now. You can create a new project application or a new module library, but you cannot create a new project library. Guess which one we need. But there's a couple of options here how to solve this. And the first one is a workaround to the previous slide. So you basically create an application project, you remove the application module, and you add the library module. And that's it. That's easy and straightforward, takes a few seconds and so on. Sometimes you need something a bit more advanced, or you need to automate even the creation of the project itself. And that's where command line always comes to use. The Android command comes actually with the ability to create a library project where you specify the target you want, the package name you want to use, the path to the project. You specify that you want a Gradle project and which version of the Android Gradle plugin you want to use. So it's quite a scary line, but when you break it down, it's pretty understandable what it is. So getting started. And my first suggestion is this: embrace Gradle, get out of Eclipse, get out of a... Just a question, how many of you still use Eclipse? 7 or 8. How many of those people do it because they enjoy it? One long... Oh, okay. Okay. Anyway, yeah, we all know the ADK is not really supported by Google anymore, so it's the way of the future. And Gradle is really an amazing tool. Actually, you can use Gradle with Eclipse as well if you want. But it's really powerful and flexible. And it's actually pretty easy to write plugins for it. You know, when I started using Gradle, it was pretty daunting and pretty scary. It was like, there's too much magic going on. I don't understand what I'm supposed to write to make all this stuff happen. And actually, it all came back together when I started writing the first plugin, because I had to understand a bit of the innards of Gradle, and I started putting pieces together, and it's like, it all makes sense now. So, if you have the time, invest a bit. It's learn some Groovy, some Gradle. It's a great tool. And then once you're at Gradle, I mean, there's a lot of nice plugins that you can use. The one that you should install by default is the Android SDK Manager, which you put in the first line of your build.gradle, and that will automate the downloading of the SDK, the build tools, and everything. So it's a brilliant piece of work by Jake Wharton. So what's after that? You code. And I'm not really here to teach you how to do that. You all know how to code. But there's something. The moment you decide you want to write a library, you automatically become an API designer. And API design is not easy. It's a huge subject, which I'm not going to cover here. But there's a couple of references. Effective Java, the second edition from Joshua Block. And from Joshua Block, there's also a very nice presentation, how to design a good API and why it matters. As you can see, Joshua is basically the leader. He's a Java genius. He wrote the whole collections framework for Java. And while I'm at it, I just want to share one of these slides that I want to make it yours as well. It's what makes a good API. A good API has to be easy to learn. And it has to be easy to use, even without reading the documentation. And the third point is kind of hard to achieve, but it's really important. It has to be hard to misuse. Once you write a library and you put it out there, you have no idea how your users are going to use the actual library. And they will come back with lots of questions like, oh, this doesn't work as expected, or this and this. So try to make your library as clear as possible and make it hard to misuse. It has to be easy to read and maintain, because you will have to deal with that code for a while, especially if you make the code public. You will have to maintain it. And it has to be powerful enough so that you can do what you have to do, but sometimes you have to be strong and say no to some feature request, because you cannot make everybody happy. You don't want your library to become a monster with tentacles trying to do everything. If it has to do one thing, make it do one thing and do it well. And choose your audience. That's also very important. It's related to what I said before. Don't try to make everybody happy. Make one task good, and that's it. So that's about coding. Testing. Some might argue that you might want to do that before coding. If you want, you can cheat with Git. You can invert the order of the commits, so people think you do TDD. Testing, of course, is super important in software design, but even more so for libraries. Luckily, writing unit tests for Android libraries is basically just as writing unit tests for Android applications. So you already know how to do that. You can still use Android test case, so you can get context from there. You can do all kinds of things. But JUnit 3 is not so nice to use, I would say. Now something is changing, and JUnit 4 support is being added, but it's not really complete yet. And one feature that is really missing from JUnit 3 is video. No, okay. is parametric tests, which means that you want to test a specific method with a lot of different parameters and see that you always get the expected result. You don't want to test with one single pair of values and see, okay, it works now. Fine, that's it. There's a solution for this as well, and it's a library from Square called Burst. Okay, again, thank you to the Square guys. They do a lot of work, and most of it is really, really high quality, so props to them. Related to testing, automate your tests as much as possible. Anything that you find tedious or boring, just automate it if you can. And Jenkins is a wonderful tool for that. I don't know how many of you use it or how many of you like it, but it's extremely flexible. It's the most flexible out there for sure. And there's more than 1,000 plugins out there. So there's most likely exactly what you need. Up to date, yeah, there's more than 1,000. I think the milestone has been reached late last year. And some of those plugins are actually specific for Android development. So here's my list of must-have Jenkins plugins. The first plugin I always install is the job config history plugin. It's not Android related, but it's really important. It helps you to keep track of the changes you make to the configuration, and also it keeps track of who does those changes. So if somebody breaks the build, you can point fingers. Git plugin, no-brainer, and it has the cousins, GitHub plugin, GitHub request builder plugin, and so on. There's a bunch of them, and they're all very nice. I mean, and if you're using some other service that's not GitHub, there's plugins for those as well. There's GitLab, there's Garrett, there's all kinds of plugins for Jenkins. The Gradle plugin, of course, and what allows you could actually just run a shell script that says, okay, just run the Gradle wrapper, but this will package it in a nicer way and will show you the progress in Gradle format, and it's pretty nice. You can specify which Gradle file you want to use if you don't want to use the default one. It asks you if you want to use the Gradle wrapper or not, and so it has a few options and they're all useful, so just get it and use it. The Android emulator plugin. This is extremely important, especially for app developers. What it allows you, actually the name is a bit misleading. It doesn't only do emulator stuff, it does a lot more. But yeah, that's how it's called. And, but basically what it allows you to spawn up an emulator and run the app on it, and you can run monkey tests on it, and nice reports about your monkey tests and unit tests and everything. So it's pretty well done, and combined with some of the features that Jenkins comes with out of the box, such as the JUnit plugin, the matrix job plugin, that's super powerful. This means that you can do a Jenkins job where you define an axis for several resolutions of screen resolutions and an axis for the Android version, and that you can test the whole array and see that everything works in every single occasion. So that's super powerful for app developers. For a library developer, I mean, you don't have to care about screen resolution most of the time if you don't do UI plugins, but still, it's super powerful to be able to choose and test several versions of Android. Another way to test your app is actually, or test your library, is to write some example apps. That is important for several reasons. First of all, you validate your use case. So you make sure that you actually fulfilling something that is useful in an app. It's also useful to showcase what your library can do, and indirectly it also serves as documentation. Your users can see what the test app is doing and how you use the library, and that's the right way to use the library. So that's like best practices. Remember to run the monkey tester on those apps. So you can see that there's no unresponsive apps or that you're doing threading correctly and all these kind of complicated things that can break up. And once again, just use Jenkins to do that. There's actually a useful Gradle plugin that allows you to run any command in an Android device, so you can do all kinds of things. You can even use it for running monkey test as well if you don't want to use the emulator plugin for Jenkins, if you just want to use some other CI system, whatever. And I actually did a couple of contributions to this plugin so that you can specify the seed of your monkey test so that you can actually reproduce the error on your machine. That's very important to be able to reproduce the error. So once you've done all this, it's finally time to publish your library. And here you have a choice. You can use normal jars, or you can use AARs, Android archives. And there's a few considerations to make on whether you want to, which one you want to use. AAR is perfectly supported by Gradle and Android Studio, so you have no problems there. But AAR is not supported by Ant and Eclipse. So if you intend to support Eclipse users, then you have no choice. Also, using local AAR files is non-trivial. What does this mean? When you have a big Gradle project with sub-projects, so one of the sub-projects will be the library, and some of the other sub-projects will actually be your test apps, and you want to use the AAR file that you just compiled. That is trivial to do with the jar files, but it's not as easy to do with AAR. It's possible, and there are a couple of ways to do it, but it's not as nice as with the jar files. Actually, the Gradle Android plugins come with, at the very bottom of the page, of the web page, there's a link to a samples zip file. And in there, there's actually some examples of how to do this. So the bottom line is, if you want to support Eclipse, you have no choice, use jar. And that comes with some consequences. One of them is that when you generate a library with the Android Gradle plugin, it will by default generate an AAR for you. So how do you actually generate a jar instead? And this is the way to do it. The trick here is that the AAR file actually already contains the jar file, and it's called classes.jar. So all you have to do is just to take that jar file, rename it, and you're done. This is Gradle syntax, and I specify a task of type copy. And it depends on assemble, so you know that at that time actually everything has been built. And you copy from the intermediate classes.jar, and that path is always the same. And you copy into build libs, which is where the Java plugin puts jar files. And while you're at it, just rename the jar file to whatever you want it to be. So it's pretty easy. So the next question is where to publish. Luckily, the answer to this is very easy. Most of you are app developers, so you don't know this, so I'll just put it here. Bin tray is just the go-to solution for storing jars. If you know JCenter, it's actually the Maven expansion of bin tray. And JCenter is actually a superset of Maven Central. So once you import JCenter, you have everything. And actually, I think by now the Android Gradle plugin will automatically include JCenter instead of Maven Central. So it works very nicely. I don't know if you ever try to publish something on Maven Central, and it's hell. it's not nice at all. This is super easy. There are some requisites that you need to fulfill. When you publish something, wherever you want to publish, you need to provide a sources jar file, which is basically just a jar file containing the source of your library. And this is a one-liner in Gradle. So it's a jar task that just takes that. So Android, that's the Android plugin namespace. The source sets main Java source dirs. That's it. This will generate a jar file with a proper everything. It's perfect to be sent up. You need another jar file, and it's the javadoc jar. It looks a bit more complicated, and it is, but we can break it down. So first of all, I iterate through all the variants, and variants are release and debug, but you can actually define your own variants. Then I define a task that it's called javadoc release or javadoc debug, and it's of type javadoc, and that's where the source is. And I define this variable Android jar. This is the only trick that it's not intuitive, and it takes some googling, but it's easily doable. I use the library, that path afterwards. So the class path is whatever you define plus Android jar. And that's just to be able to link to Android-specific classes and so on. So if in your documentation you mention Looper, then you can click on Looper and go see the Android documentation for Looper. And you want to exclude the build config and r.java. People are not really interested in that in your javadoc. And Beantray actually provides a Gradle plugin, which is a bit scary. I mean, the configuration is something like 20, 30 lines. So it can be a bit scary, especially if you're new to Gradle. So in the beginning, you can just use the web interface, upload those 3 jar files, define the version number, and you're done. Once you used to that, and actually when that becomes annoying, then we will actually learn Gradle and do the automated way. So that's my suggestion. Something a bit more of an advanced topic, the notation processor. It actually is becoming quite a trend in library developers in Android to use annotation processing quite heavily. And that's because it allows you to do some things that are expensive to do at runtime and do it at compile time instead. So whatever piece of information you actually have at compile time, you use it there, and then generate whatever you need to generate at compile time, and then use it at runtime. And yes, you can write your own annotation processor. It's not super easy, but it's completely doable, and it's also fairly well documented. And there's quite a few libraries now that use it, so there's plenty of inspiration to get from those libraries. And as I say, the notation processing is good at solving a couple of problems. Boilerplate removal, so code that you're writing and you don't really want to be writing, and introspection removal. Introspection is very, very slow in the Android runtime, so try to do that at compile time if you can. So some examples of libraries, popular libraries that use annotation processing. Dagger 2, I guess you all know it and love it, I hope. Butter knife, which is injection for views and a lot more. Auto value and auto parcel, which basically allow you to not having to write the implementation for getters and setters and hash code and toString and so on. Brown uses annotation processing quite heavily. So it's all good and dandy. Well, not. the Android API doesn't support this specific package, so the JavaX annotation processing package is not supported. So that means you have to work your way around the problem. Specifically in this way. You basically need to create a couple more Java sub-projects to your Gradle project, and one contains the annotations and one contains the actual annotation processor. And they need to be separate because actually the annotations, you will need those also in your actual library, the Android project. So yeah, just picture the graph in your head and you figure out why you need two different packages. So that means also that your build environment will get a little bit more complicated compared to what I showed you before. So the generation of the jar file now is slightly different. And basically, you need to include not only the class.jar file, but also the contents of the processor and the contents of the annotations. This zip tree is actually a pretty nifty function that's available in Gradle that just unzips a zip file, which a jar basically is, and posts the list of files for you. So it's pretty easy and straightforward. And also the Java.task task will have to be modified because you also need the documentation for your annotations. And it's one line that you have to change. As you can see, the first line where I mentioned the source, there's an equal sign, and in the second, there's not. That's not a typo. That's actually the way it's meant to be. The first one is an assignment. So I say the source set is that. The second one is a function. So say add to the source set this other one. So it's not a typo. Be aware of that. Yes. Native code. How many of you have to deal with the NDK? That's a fair amount. That's good. Unfortunately, the situation with the Gradle plugin and Android Studio regarding the NDK, it's this. Right now, when you try to build a project that contains NDK, it comes out with this warning here saying, current NDK is deprecated, don't use it. Something better will come in the future, whatever that means. I spent a fair amount of time trying to mean what that in the future means, which means that I have I cloned a repo of the Android tooling in my computer, and every day I do a git pull and see what's going on. And what's going on is that they have created a folder called Gradle Experimental. And in there's a lot of activity dealing with NDK and so on. So I don't know why they did it in a new folder and not in a branch, but that's the way it is. So I don't know. A few days ago, there was the beta coming out for 1.2 of the Gradle Android plugin, and there was still no mention about NDK. And this is the situation I'm in at the moment. So Google is driving and in the back seat, like, are we there yet? Are we there yet? And we are not there yet. What can we do about it? The first solution is ignoring the warning and just use the NDK. It works fine. It's pretty stable. There's not many surprises coming if you use it. And also, if you look into what I mentioned above, this sample.zip that comes with the Android Gradle plugin, actually they have a bunch of examples in there how to use the NDK. And this San Angeles is one of them. And this is how you define. So you define this NDK closure and the module name, what C flags you want to use when compiling, which libraries you need to be using, and what version of the standard template library if you use C++. There's one big lack that in our particular case is very important. So there's no way to define LD flags. So you cannot specify flags that are only related to the linker. which means normally you don't really need them, but if you need to do some more advanced things like link time optimization or other kinds of things, then it kind of kills our workflow, so we cannot use this solution. Speaking of which, I wrote a blog post about actually how to use various options to reduce the size of native libraries for Android, but that's a bit out of topic. The second solution is to use the native Gradle plugin. Gradle is very active in trying to responding to the Google needs. And one of the Google needs, of course, is to actually improve NDK. When Google first implemented NDK, they decided not to use the built-in support for native code in Gradle and build their own framework. And that turned out to be a dead-end road. And probably they regret it, but Gradle 2.3 got released last month, and it has a heavily reworked native interface, and I suspect that it was a lot of those changes were dictated by Google. Some problems that this approach might have is that it requires extra logic because you have to define your own standalone tool chains and so on, all the things that the Android plugin does for you. And it also might become obsolete as soon as Google releases their NDK, proper NDK support. Another question is, okay, you have a jar file. You decided to push a jar file to your users. How do you include native code in there? It's not something that you usually do. Usually when you have a jar file, it depends on the fact that you have already installed a dynamic library on your computer and so on. But that's not something that it's easy to do to your users. So actually there's a standard that you can follow. So here I simply unzipped a jar file. So you can see there's the manifest, there's the actual class files, and then there's this lib folder, and then in it there's subfolders for every architecture. And in there's the library with the same name all over. Built for the different libraries. And actually, right now the list is much, much longer. So there's also ARM64, there's Intel 64, there's MIPS and MIPS 64. So it's quite a big list. How to generate this jar file in Gradle? Well, once again, it's just a few lines of Gradle, and you just put everything you need into the lib folder, as I showed. And the type of the task is jar, so that will take care of actually packaging everything and zipping down the contents and making a jar file. So that's not so complicated. So these are the things that I would like you to remember out of this presentation. Embrace Gradle. Don't be afraid of it. I know it can be scary, but it's worth the time you spend on it. And explore the Gradle plugins ecosystem. It's big, it's very vital, there's lots of plugins going on, and it's much like the Jenkins interface. Once you have something that is very easily to plug into, then you also grow this big ecosystem of useful things. And that's what's happening to Gradle, and I really like that. Automate your tests. Automate actually everything you can, not only your tests, because I mean none of us wants to do boring things. Automate, use Jenkins or whatever other CI system you want to use, and write scripts and so on. So it's worth your time. And also considering testing is something that it's easy to forget before you push. So just automate that as well. Beantray is a go-to solution for publishing your libraries. Don't look anywhere else. Don't try to deal with Maven Central. It's for your brain sanity. And writing libraries rocks. It's fun, it's hard, but it's rewarding. So if you manage to write smart code and you want to make it public, please do it. We all need it and we all benefit from it. So that was it. Thank you very much for coming. Hope you enjoyed it.